Hey there, welcome to a video discussing the second half of the 2.4 notes. Here we're going to go over example 4. Our function is x cubed minus 2x, and we're going to find the slope of the curve at x equals 2, the equation of the tangent line at this point, and the equation of the normal line. Now I did set this up during our last class meeting, but I will just go about this from scratch and do it again. And of course, I'll do all the algebra required to solve this problem. Now, really what part A is asking us to do is find the slope of the tangent line at x equals 2. So that's really what it's asking us to do here. So if this curve kind of looks like this, I think it has a 3x intercepts, I think one at root 2 and negative root 2. Kind of like that, right? And x equals 2 is probably somewhere over here. So we expect a pretty steep positive slope. So let's work this out. So you take the limit as h approaches 0 of f of 2 plus h minus f of 2 over h. Remember, a equals 2. That's the point, that's the x coordinate of the point of tangency. So my point of tangency here will be at 2 comma 4. Of course, if you plug in 2 into the function, you get 4 coming out. So let's work this out. The limit as h approaches 0. So you can plug in 2 plus h into our function. And of course, plug in 2. Now you will have to expand this. It's a little crazy, but you can think of a being 2 and h being, or b being h here. So if I work that out, I think that's going to be 8 plus 3 times 4 times h plus 3 times 2 times h squared plus h cubed minus 4 minus 2h. All that is going to be 8 minus 4 in there. So be very careful. Also, it's true that negative 2 to both the 2 and the h there, all over h. Keep working out. You get 8 plus 12h plus 6h squared plus h cubed minus 4 minus 2h. And then that's a 4 here, so that's another minus 4. All over h. Limits as h approaches 0. Now, fortunately, some things will go away. The 8 and the 2 negative 4s will cross off. Leave with a bunch of h's up top. And we'd see an opportunity where we can combine like terms. So I'll do that right now. And it didn't leave myself much space, but that's okay. The limit as h approaches 0. 12h minus 2h is 10h. Plus 6h squared plus h cubed over h. As h approaches 0, factor on h. Those cancel. And then you can plug in 0 for h. And if you do that, you should get 10 plus 6 times 0 plus 0 squared. And of course, the answer is just 10 straight up. So that's going to be the slope of our tangent line. It's going to be 10. And so it makes sense graphically because it does look pretty steep there. Then for B and C, those should be pretty straightforward. I'll change colors. That's going to be y minus 4, 10 times x minus 2. Remember, x is 2, y is 4, right? The normal line, just do a negative reciprocal for the slope. Y minus 4 equals negative 1/10 x minus 2. So those are super easy. So that's what's happening for example 4. Okay, I'm going to clear the screen and move on to example 5. Example 5. Okay, determine the slope of the curve, of that curve, y equals 1 over x minus 3 at x equals 5. Graphically, it looks like this. Vertical asymptote at 3. Horizontal asymptote at y equals 0. Just, knowing if you know your rational functions. So x equals 5 is going to be somewhere over here, probably. So I'm probably expecting like a negative slope. But let's work it out. The limit is h approaches 0. And we can call this like f of x if you like. So it'll be f of 5 plus h minus f of 5 over h. So we're doing 1 over 5 plus h minus 3 minus 1 over 5 minus 3 all over h. The limit as h approaches 0. Now, of course, this is 1/2. And that's 1 over 2 plus h and h. And let's not get lazy, so write the limit notation. And your LCD is going to be 2 times 2 plus h. So I'll multiply this by 2 and 2. And multiply this by 2 plus h. Keep going. The limit as h approaches 0 of 2 minus, and the denominators combine. I mean, they're the same, so it's 2 times 2 plus h. And down below you have h. And I'll think this is h over 1, by the way. That h right there. So what's going to happen is that you distribute the minus. 2 minus 2 goes away, then you have negative h. Times 1 over h, you flip over that bottom fraction. H's cancel. So now you're taking the limit as h approaches 0 of negative 1 over 2 times 2 plus h. Now I can plug in 0 straight up, and I get negative 1/4. And that looks like a negative 1/4 slope to me. So that's example 5. Again, you'll have an opportunity to do these for homework. I'll assign odd problems so you can check the answers in the back of the book, and I'll even provide the answers too, not a problem. Okay, so hopefully we are good there. And lastly, example 6. Now, example 6 is asking you, kind of working backwards here. At what point does the tangent to the curve of that have slope is equal to 4 or 0? Now, this is a parabola. I think the y-intercept is 1. I believe it's going to kind of look like this, but not 100% sure. So anyway, we kind of expect at 4 to have a positive slope, at 0 probably a negative slope. But here you're asked to find, here you're given the slope, right? And you want to find at what point does the tangent to the curve have those slopes. So let's look at part A. So remember, limit as h approaches 0 of f of a plus h minus f of a over h equals our slope, right? So now you're working backwards. I know the slope is 4. And if I plug in, excuse me, a plus h into this, and of course minus a squared minus 3a plus 1. I have to tuck that in there, sorry about that, over h. So limit as h approaches 0. Now let's work that out. A squared plus 2ah plus h squared minus 3a minus 3h plus 1 minus a squared plus 3a minus 1 over h equals 4. Now there should be a lot of cancellation if you do this correctly. Boom, 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 boom. And now I can actually factor out 2ah plus h squared minus 3h. Just try and be very careful. A lot of terms here, mind you. All over h. That limit is equaling 4. Well, obviously, I can factor on h. Once h approaches 0, plot h here. 2a plus h minus 3, I think. Yeah. All over h equals 4. These h's cancel. Now I can plug in 0 for h. So you get 2a minus 3 equals 4. 2a equals 7. A equals 7 halves. Which kind of makes sense that if I have 3.5 here for x, that would be the x value at 3.5. So this would happen at x equals 3.5. And to find the y coordinate, you throw it back in the equation. Too lazy to get my calculator. Get my cell phone out here. Let's see here. 3.5 times 3.5 minus 3 times 3.5 plus 1. So the y value is going to be 2.75. So the answer would be at 3.5 comma 2.75. That would be part A. And usually it's a good idea to check the answer key. Actually, I did not do that before I started these notes. So let me do that really, really quickly here. Fill out notes. 2.4. That's not worked out. It's okay. I trust I've done this correctly. So, but yeah, so that's how you do part A. So again, you're trying to find the x coordinate of the point of tangency if the slope is 4. Let's do this now when the slope is 0. And actually, I don't know why I drew that tangent line. That made no sense. You want the tangent line to be 0, not at x equals 4. Sorry, I totally read this incorrectly. So if I confused you, my apologies. Actually, it might be a good question to ask in the Google Doc. Wow, I can't believe I did that. So hopefully I didn't confuse you. I might put a little note in the Schoology. Hopefully you guys will see that. So sorry, we're trying to find where the tangent line is 4, not when x is 4. Of course, when the tangent line is 0 here. The tangent line is going to be 0 most likely at the vertex, which I know is going to be at 1.5 for x. But let's just work it out. We'll do it again, one more time. Actually, I won't erase the whole thing. Actually, I'm being kind of lame here. Actually, I can keep all this. We could just change this to 0. And that to 0. No need to redo the whole thing again. We don't have to reinvent the wheel. That's 0. That's 0. And that's 0. Now you solve for a. You get a equals 1.5. Which makes sense because that's where the vertex is. Because the vertex is a low point, and if you draw a tangent line, that's definitely going to be horizontal. Likewise, if it was a high point. And the y value there, let's work that out. 1.5 times 1.5 minus 3 times 1.5 plus 1. So it should be below the x-axis. I kind of messed that one up. That's okay. On the diagram, so negative 1.25. So there we go. Now we got this all figured out. There's a way you could actually use a graphic calculator to help you solve for this stuff. We're not there yet because we haven't really done derivatives, but we will do that eventually. So that concludes the video for the rest of the 2.4 notes.